Hello, guys. Today we are going to continue with our course, the lesson number 3, and I consider this is from the basis the most fundamental topic we have to talk about. This is very important to know how you store the data in your computer. Okay, this is very important, guys. So please share this video with your friends. Subscribe on Tekniikka High Tech on Facebook, YouTube, and Instagram, and also we also on Twitter and on LinkedIn. Okay, so talking about data types in the C programming language. Let me just check my audio. Yeah, that's fine. Talking about the data type today, we're gonna have an introduction. After an introduction, we're gonna talk about the data types themselves and just that. We're gonna perform some exercises as well after that. Um, in C, in the C programming language, the C programming language is the basis of the programming. Okay, all the languages, even if you don't see these concepts in most of the languages, they are abstracted some way that you cannot see, but they are there. If you know this concept, um, you'll be able to understand most of the language quite easily. So the first data type is integer. The integer numbers are non-floating point numbers. These are numbers of 8, 16, 32, and 64 bits. And we also have real numbers, like in mathematics. Real numbers, these are floating point numbers. We have 32, 64, 80, 96, and 128 bits. Okay, and then we have the smallest addressable unit of the machine that can contain basic character sets. This represents basic keyboard symbols like letters, numbers, punctuation, all the special characters that you can see on your keyboard. The characters are all represented by the ASCII table. We can take a look on the ASCII table as well. Each character is only 8 bits. As you can see, the smallest number is also integer number is also 8 bits. That means that the characters are stored on the same kind of addresses as the smallest number. By the way, as a matter of fact, the characters are also stored as numbers. Okay, this is why on last lesson, maybe on the first lesson, when we talked about data and information, we talked about numbers, and from the numbers we can convert from binary, octal, hexadecimal, decimals, and also characters, and all the information that you can see on your smartphones and computers. So this is the table to represent all the characters that we can have. As you can see, we have 3 types of characters. The first one is char, the basic. Um, the range is from a negative 1 to 7 to a positive 127. Okay, all of them are 80 bit size, but the difference is on the format. As you can see, here, if you want to print, for example, a char, you use percent, the percent symbol, and C, or HHI. Okay, signed char is the same as char. As you can see, the range is the same, This is the default. The default is signed. If you don't write signed, you are using char. If you don't write here as signed, you use signed char by default. But this is different. This is unsigned, and this is only numbers from 0 to 127. Only positive numbers. This is the same as you can see. Let me take a look. This is all the same on the format. No differences. No difference here. No difference here. Okay, no problem. And we have the integer numbers. The integer numbers are numbers from 16 to 32 bits. The smallest is like a char. This is like a char. This is the smallest range, the smallest integer number, and this is the biggest, the largest integer number. And to print a short, you write hi or hd. That's the same. This means this stands for short, and this is integer, and this is decimal. Okay, same here. You write this is assigned short, which is the same. The only difference is this one, unsigned short. As you can see here, the unsigned, this is 2 times this. Okay, because the the space we are not using on negative numbers, we penalize the positives. Okay, from 0 to this one. And the size is the same, but the difference is here on the format. Since we have I or D, here we have U, which stands for unsigned. This is the regular integer number, and the range is from these two, pow 32. Okay, divided by 2. This is divided by 2. Divide by 2 because this is signed. Because this is signed, we have one half for the negative numbers and another half for the positives. Okay, this is why we have I, which stands for integer. This stands for decimal. Here the sign, that's pretty much the same. But this is different. Unsigned, as you can see, from 0 only positives, and here we don't have the division by 2. Because we canalized all the negative to the positives. Okay, this is only an observation that I didn't write here. For example, here for example, here these numbers, this is -1. I didn't write here minus 1 because I didn't have space. This is -1. This is also -1, like here. So these are the bigger integers. The bigger integers, we have long. For long, we have 32 bits. Let me give you an observation. These I put here 16 or 32, but most of the time int will be 32. Okay, most of the time this is 32, not 16. For here, we have the long is 32. I also saw some systems, it depends on the operating systems and on the compiler sometimes, because the long sometimes might have 64 instead of 32. You must be careful about it. So let's consider that a long is 32 and a long is a 64. Okay, for this, that's pretty much the same. This is 2 power this number divided by 2. This is divided by 2 because this is negative and positive, since this is signed by default. This is signed, but for unsigned we have all positives. This is the same, pretty much the same for long. We have this range. negatives and positives. Negatives and positives because this is the same. But unsigned is different. This is why we have the biggest. We can have the biggest positive here using unsigned long, a huge number. You'll see on the compiler. Okay, that's fine. For long, we have long integer or long decimal, long integer or long decimal. Long unsigned, okay? This is long integer, long decimal, long that's the same, long unsigned. Okay, we at the end of our theoretical lesson. These are the floating point numbers, the real numbers. For the real numbers, we have float, which is 32 bits, and we have double 64. But we have this this one is long double. This is huge. We have 80, 96, or 128 bits for a number. So let me just check it out. Okay, that's fine. For float, you use F, you use G, or use E or A. That's all the same, but basically you like to use F, which stands for float. For double, we have long float because this is long float actually. Long float, long G, long E, long A. I prefer long float. For long double, we use long float. This is capital long, capital L, capital long float. That's the same. So thanks for watching so far. We didn't finish yet. Let's code a little bit right now. Let me. Okay, that's fine. The time is fine. So we can code a little bit. Let's open a compiler right now. See online. This is a compiler we've been using. Let me put only codes here. Let me select here the C language and let me delete all the code here. Okay. Let's start from scratch. I have a comment here. Some guy, a colleague of mine, is coming after the lesson. I'll read the comment. So let's go to our GitHub. This is our GitHub. In our GitHub, I have our course in English is maybe let me look for first, not this one. This one. This is our course in English, and here I will be putting the codes here. This is our first code we used on the first lesson. Let me copy this, our brand new code, and let's use it on our compiler. As you can see, let me delete this. This is the header of the code. This is a comment. Okay, this is a comment. Doesn't matter to delete. This is another comment. This is the begin. The begin is the calibrace. This is the end, another calibrace. So this is the main program. Now we have 6 lines, only 6 lines. That's fine. So let me compile this by run. Let me put it a little bit bigger. So let's run. Okay, when I run the code, we have hello guys. We printed hello guys. So right now, let's use our concepts. We have here our concepts. Let's start from characters, this table. So right now, we can print here. This is considered in programming. This is a sequence of lots of characters. This is a character. This is another characters. This is another one. Another one. So much characters. Okay. Let me delete. The printf function has 2 parts. The first part is this one where you put these codes from the format. Okay. For example, we have a char. We want to print a char. You put % and you put this is C. You put C, as you can see here, SC, and then after this is the format. After this, you put a comma, and then you put the char. For example, the letter A. Okay, what is A? What is the numerical value of A? You don't know yet. I know. You don't know yet, probably. So this is A. Let me run the code, and you have here A. Okay, this is A. That's fine. What if you want to have the A, the numerical value of A? Numerical value of A is the ASCII value of A. The ASCII value of A, we can print it using HHI like this. This is a char. We use C or HHI. Let's use HHI here. Instead of C, let's put HHI. If you have HHI, we'll have the numerical value. The numerical value of A is 96. If you didn't know it, if you didn't know, I'm telling you that that's right. This is 96. How do we how do we be sure that this value is correct? Let's take a look on the ASCII table. On Google, you can write ASCII table, for example, and you have a bunch of ASCII tables. I don't know which one is the better, which one is the best. This, I don't like this. I think I also don't like this. Okay, I don't like this. Okay, maybe this one will be fine. No, no, no. This is not good for reading. What about this one? Not also good. Not also good. This one. This must be fine. Okay, this is fantastic. Yeah, this is fun. This is good. Okay, as you can see here, you have this. This is separate. This is, I don't like this because we have some characters from the center to the left, and another characters from the center to the right. So this is the A. As you can see, this is the capital A. Okay, the numerical value of capital A is 65. Okay, this is decimal, and you have the octal, and you have the hexadecimal. Okay, what about the lower, the lowercase a, the lowercase a? The lowercase a is 97. 97 is here. Okay, this is 97. Now you know, as you can see, 60, 65. You can put to right a like this, a, and you have 65. Okay, what about the opposite? About the opposite, let us try to use the opposite. Let's we put here the 60, 65, for example, and you run. You have 65 because you have HHI. Okay, if you write C, you have the ASCII value of this, which is the capital A. That's fantastic, man. Yeah. So from now on, we already know how to use this. And let's take a look at some overflow. As you know that um, we on our table here we go from 0 to 127. Okay, 127. You have 127. You'll get here the ASCII value of 127. This is not printable. I don't know why this is not printable. Let's take a look on the table. 127, maybe this way, this side, not this, but this side. 127 is maybe here. 127 is the deal's characters, the character to delete from the left to the right. You cannot see because it's not printable. So let's print this one. This is 126. So 126, we have this. Okay, that's fantastic. Let's go to some integer value. For integers, we have this table, And this is amazing because right now we are going to talk about a very important topic which might introduce lots of bugs on the softwares. This is very important because most of the softwares have bugs because of this. Okay, let's use a short. Okay, you know that this is the biggest short. Okay, this is the biggest short. This one we'll have here short. What is short? Is that H? Maybe H. Short is HI. Okay, HI. And HI, this is the longest HI. Okay, let's delete this one. And now you can see that's fine. You have this number, this integer, which is the the largest short int. Okay, this is the largest short, and the small short might be this one, the same number with negative value. This one, this is the smallest. Okay, what if we want to write a short, but we go beyond the limits? Let's go a little bit beyond the limits. This is 67 at the end. Let's put 68. Let's see what happens. This is what happens. Okay, this is what happens. This is an overflow. You were at the limit, you were at the limit, and then you wanted to write the next positive number, but you got a negative number. This happens because on a short you don't have more space to save this number. This is why you have an overflow. If you're writing a software and you don't know the data type and you don't use the right data type, you might have bugs, you might have issues. Your users might complain about your implementation because it's poor. Okay, so let's take a look on another example. For example, this is an int, a normal int. This is a short int. This is a normal int, which is only IOD. Let's check it out. So take it out, just I. With an int, since the limit of int is something like this, a huge number. This is a huge number, okay? You can use this. You can use this is an int. For an int, you don't have the overflow right here, okay? That's fantastic. Let's take a look on another examples of our table. What we have? These are signed and unsigned. Okay. I don't see lots of problems here. Let's play with this unsigned. This unsigned. You. Let's play with unsigned. We put unsigned here, and then we want to use, for example, this a negative value. What happens if we put a negative value on an unsigned? Let's check it out. You got a positive value, man. You think that's magic, but that isn't. You have to respect the data types. This is why I taught this table. You have to pay to pay lot of attention when you're using a data type. On the next session, on the next lesson, on the lesson 4, we are going to talk about variables. And when we define variables, we set a data type for that variable, and we will have to set the proper data types, not to have these kind of issues. What else? What else we have? Float. Okay, I think that's fine. That's fine. And here long, but I think you already understood. If you have some doubts about data types, okay, put in the comments. I will respond you as soon as possible. Don't forget to subscribe our channel on YouTube, put a like on Facebook, on Instagram as well, and follow us on Twitter, okay? Thank you very much for watching. I'll see you next time, next week, talking about variables, okay? See you. Thanks a lot. Fantastic.